Hi, welcome to this video on power factor topic. So power factor in AC circuit is the ratio between the true power and the apparent power of a load in an AC circuit. So power factor is purely depending on the type of the load. Okay, so as we have studied, if you have a capacitive load, then the current is leading and the power factor cos phi is it's a better power factor. You have a leading power factor. When it is inductive, it has a lacking power factor because I is lacking here. So if you look at this power triangle here, so this is phi, this is the P, that is the true power, and this is the active power Q, which is represented by Q, and S represents the apparent power. So the power angle shows that this ratio is the cosine of the angle between true power and apparent power. So this is the same angle as the phase angle between current and voltage in the phasor diagram what we discussed. So the power factor cos phi is nothing but the power factor cos phi. So cos phi is nothing but opposite side by adjacent pi, that is Q by P. Correct. So Q by P, or you can say, cos phi is adjacent side by hypotenuse. We can say that is P by S. So tan phi is opposite side by adjacent side, that is Q by P. So in this case, inductive loads always have a lagging power factor and capacitive loads always have a leading power factor. So since the real power cannot be greater than the apparent power, the power factor cannot be greater than 1. So we can define the power factor in different definitions. So one, we can say it is defined as the power factor by which apparent power must be multiplied by in order to obtain the true power. So we can write power factor is nothing but true power, okay, divided by apparent power. So if you look at this triangle, so this is the power factor. So power factor means cos phi. So cos phi is equal to adjacent side by hypotenuse. So P by S. So that is what I have written here. P by true power is P by S. Look at this. True power is P. So true power is P by S. So S is your apparent power. So power factor can be written by P by S. That is what we have written here. So it is the factor which decides the true power consumption in the circuit. So the numerical value of cosine of the phase angle between the applied voltage and the current drawn from the supply voltage gives the power factor. So between cos phi is the angle phi is the angle between V and I. So we can say it is a numerical value of cosine of the phase angle between the applied voltage and the current drawn from the supply. So cos phi can also be defined as cos phi is equal to R by Z. If you take an impedance triangle, correct? So if this is phi and this is P and this is Q and this is S. So if you take this impedance triangle, this can be R, this can be X, correct? And this can be Z. So in that case, cos phi is nothing but R by Z. This is also one way of definition. We can define the power factor. So the current lacks the voltage power, current lacks voltage, if the current lacks the voltage, power factor is said to be lacking. So current lacks voltage. Okay, then P power factor is lacking. If current leads voltage, then power factor is leading. Correct, power factor is leading. So we'll discuss more on this using this power factor by taking a cappuccino here. So in this circuit, the simple analogy to explain the power factor is that using this cappuccino. Here, a mug must have sufficient capacity to contain both the coffee and the froth. So corresponding to the total power. Correct. So, apparent power is the whole cappuccino you pay. Correct, no? So, but actually the real power is what you are utilizing. But you are paying for the reactive power also here. So let me explain that. The froth represents the reactive power, and the liquid, the actual coffee, represents the real power. But we are paying for both the froth and the coffee. So it is just like froth, you enjoy the better quality of the coffee. Correct. So we can gain real value from the liquid. So only for the real value means we have to take a particular coffee, in a liquid form. Froth form is just a topping of that. Correct. But it appearance and the quality wise, you enjoy that coffee with the froth. So reactive power is something, the quality of that can be improved in the power. So there are varieties of ways to measure the power factor. So lagging devices on equipment, more complicated measurement, and lagging equipment installed on individual circuits. So if you don't have the skills in house, you may engage an external specialist to help you to assess your power factor and identify any causes and solutions to improving your power factor. See, whenever there is a less power factor, the quality of the power can be down. So there are varieties of reasons that a site may have poor power factor, but the main causes normally is inductive loads such as transformers, AC motors, welding equipment, arc furnaces, and fluorescent lighting. So all these, using such kinds of loads can, reduce the power factor. So the more the power factor, the quality of the power is more. So benefits of improving this power factor. So before that, let us see the comparison of power factor here. So if you take up a resistive load, current, voltage and current both are in phase. So the cos phi is 0. Correct? No, cos phi is 1 because phi is 0 here. Because V and I, phi is 0 here. It is starting at the same. There is no difference. But if you observe here in inductive load, so current is lagging this voltage by an angle phi. So the inductive load has a lagging power factor. When you take a capacitive load, current is now leading the voltage by 90 degree. Correct, na? So if you observe, this is current. So if you look at this current and this voltage, it is leading the voltage by 90 degree. So it has a leading power factor. So now, what are the ways or benefits of increasing the power factor? First one is reducing demand charges. So if you improve the power factor, it will reduce the demand charges. Okay, it reduces the demand charges. So improving the power factor means that is nothing but using in the capacitive load than inductive. But most of the industries are having lagging power factor because they use the inductive load, and therefore we need to improve the power factor by injecting the reactive power into the circuit. So by improving the power factor, these are the benefits, that is reducing demand charges to reduce your demand on the electricity networks, which may lower your electricity cost. If you are one of the small number of consumers or customers currently being charged under a kVA demand tariff, so that might reduce the demand charges. And second one, it have contractual compliance. Okay, contractual compliance. So to help you meet your connection requirements outlined under your connection agreement. So you're meeting that compliance. And third one, increased capacity. Increased capacity. So reducing demand on the network may allow you to connect additional machinery or equipment without the need to upgrade the network. And fourth one, equipment life. So to lower voltage being supplied to equipment which can damage or otherwise shorten the life of some equipment, because when the power factor lowers, the voltage also gets lower. So in that case, it will damage the equipment also. So how to improve this power factor now? A poor power factor can be addressed in the number of ways. The most common approach is to install power factor correction equipment. We call that as PFC. So PFC is an equipment, is essentially a capacitor bank, okay, which stores and provides reactive power when required. So a poor power factor can also be corrected by fixing the problem at its source. For example, by ensuring that motors are not oversized, selecting pumping equipment with electronic variable speed devices. So we call that as VSDs. So VSDs means it is variable speed drives. Okay, so retrofitting VSTs where possible and choosing equipment that has good power factor to begin with. So these are the ways to improve the power factor. So effect of power factor in real time. As I discussed, power supply, basically after the generation is used, using transformer we step up and then transmit to the consumer. So if you have a very inductive load, where it has a lacking power factor, so you have a poor quality. So poor power factor, so will have increased power casts. So when you have a transformer with PFCs, as I discussed in the previous slide, PFCs, power factor correction, okay, so improves the quality of the power, so excellent power factor, and there will be a lot of power savings. So this is the effect of power factor in the real time. So we can use VSDs also, variable speed drives also, to improve the power factor. And thank you for watching this video.